Welcome to the Bielik method, where today I'm going to be showing you how to graph a system of equations when both of the equations are written in what's called standard form. Now in the previous video, what you saw was me graphing two lines when they're written in slope-intercept form, y equals mx plus b. But if you look at these two equations, both of them are written in what we like to call ax plus by equals c form. The x and the y are both on the left side of the equal sign. Okay? Yes, we did that to you. We're going to switch things around. We're going to make you do things out of different forms, but you need to be prepared for each and every form that you're going to see equations written in. Okay, standard form. There's a different strategy, a different way other than writing a line from slope-intercept form. In slope-intercept form, on my previous video, I showed you that you can mark the y-intercept, use the rise over the run. The unfortunate thing here, unless we move things around, we don't know what the slope is and we don't know what the y-intercept is. But we do have a strategy to get us to a line. And what that strategy is we're simply going to mark our zeros. So what I do is I put two coordinate ordered pairs written down, put a 0 in for the x, a 0 in for the y. Once you've done that, you now have an empty space on both sides. Now this is representing your x, while this is representing your y. Okay, you're going to go into each one of these equations and you're going to plug the 0 in. Okay, sometimes you can do this mentally, sometimes you're going to want to write this down depending on how tricky it is. For the purpose of you seeing what I'm doing, I'm going to be writing these down. So if my x is 0 on the first equation, that would look like 4 times 0 minus 6 times y equals 12. Meaning 4 times 0 is going to disappear. Anything times 0 is 0. Makes nothing. It makes a one-step equation. Negative 6 times something will equal 12. And the only way to make a positive by multiplying a negative is multiplying a negative times another negative. So we now know that y has to be negative 2. Meaning I want to put a negative 2 down right there. Okay, the second thing that I'm going to be doing is I'm going to be putting a 0 in now for y. Put it in right there, which is really just going to cancel out this term. It's going to make it a big 0. So here we go. I'll show that work. 4x minus 6 times 0 equals 12. This would become a 0, so we're just going to scratch that out. What you're left with is 4x equals 12. Well, most of us will probably already be able to figure that out mentally, but if you need to show the step down, divide by 4. X is going to be equal to 3. We now have 2 points that we can plot and create a line from. You simply are going to go to your graph and plot 0, negative 2, and 3, 0. These are now your intercepts. Okay, so watch as I go through this. 0, negative 2, 0 to the right, 0 to the left, down 2. Mark my point. That first dot is my first intercept, specifically my y-intercept. 3, 0, 3 over, 0 up or down would be right here. Now if I connect those two dots, I'm going to create the line of the equation that we just plugged zeros in for. I forgot my ruler again. Let me go grab that real quick. Sorry, I probably should have played like some Cardi B or something for you guys while I was gone. Okay, here we go. We're going to connect those dots. And we now have our line. Beautiful line. So lit. Okay, next we're going to find these zeros for my second equation. Same idea. Put a 0 down for x. Put a 0 down for y. Find the missing values for each of these. Okay, if I put a 0 in for x, I'm just going to cover it up this time to show you that. You don't always have to rewrite it out. Just cover that up. What you're left with is 3y equals negative 6. 3 times something equals negative 6. It's a 3. It's a positive. and it needs to become a negative, meaning your value is going to be a negative, and 3 times 2 would make that negative 6. That's our first point. Second point, negative 2, times what would make a negative 6? Negative 2 times 3 would make a negative 6. 0, negative 2, and 3, 0. Now what you're going to notice here on this equation and on this problem, we're looking for where these two lines intersect, such as this line and this line. But if you're looking at these 2 points and looking at the graph that I've already done, you're going to notice something. Okay? We have 0, negative 2 already plotted. We have 3, 0 already plotted, meaning we would create the exact same line. So if you look back on my previous video, what we are actually dealing with here is 2 lines that are right on top of one another. And what that means is that their intersecting point is infinite. It's happening throughout the entire thing. It's really not one line. It's 2 lines, one on top of each other. Okay? Back to a quick review on all that you need to know about systems when graphing. You have 3 options. You have 2 lines with different slopes. That will have one solution. You have 2 lines with the same slope but different y-intercepts. That will have no solution. And you have, yep, you guys can see that, 2 lines, one on top of each other, that are touching the entire time, which will have infinite solutions. What we are looking at right now is this one here. These 2 equations are exactly the same, okay, just written with larger values. If you were to multiply this bottom one by 2, a negative 2, it would turn into exactly what we see here. So because of that, if we were to answer this question, you would graph it, show that it's really just one line, one on top of each other, and you would say infinite solutions. Because if I put in a number here and a number here that works to make it to 6, I can put that same value in and it would work to 12. Every possible answer that you can find to make negative 6 on the bottom would also work on the top. Thank you very much for tuning into this. Please don't forget to like and subscribe to the channel, where I'll be teaching you all of algebra as well as some pre-algebra skills. Hopefully this graphing systems, you're basically going to see equations in 2 forms. You're going to see them in slope-intercept and in standard form. Standard form is what we just did. Slope-intercept is what was on the last video that I posted. And if you were ever asked to do one in slope-intercept and one in standard, it means you just would use your slope and your y-intercept for the first, your zeros, like I just showed on this video, for the second. Good luck. You guys are brilliant human beings, and you're going to do great on your upcoming test.